Okay, Mr. Kohler back working on factoring polynomials and breaking down the product into its factors. So we talked about taking on a GCF, we talked about regular trinomials, and we talked about perfect square trinomials. I have a new factoring pattern for you today. So this is going to be called the sum and difference of cubes. Now, if you recall, we had the difference of squares factoring pattern, although I didn't review this with you. But if your head is a square and the tail is a square and there's no middle and there's a minus, this thing, in fact, is the easiest factoring pattern of them all, x plus 4, x minus 4, and we've done hundreds of those. Right? That's not exactly what we're talking about here. We're going to have actual cubes. Now, you guys are probably not as familiar with cubes as you are with square numbers. So we're going to have to become a little bit familiar with cubic quantities. So perfect cubes. Guys, these are going to be things that are cube rootable. So if you think about numbers, take like the number 1. The cube root of 1 is 1. Now, if you cube 2, you get 8. So 8 is a cubic number because cube root 8 is 2. And you just start cubing numbers to get perfect cubes. So 3 cubed, 27. 4 cubed is 64. 5 is 125. I'll see how far I can go. 6 cubed is 216. 7 cubed, 343. 8 squared, 512. 9 cubed, 729. 10 cubed, maybe you know. 10 times 10 times 10, that'd be a cool 1,000. These are cubes. Now, the other thing that can be cube rootable, you guys, are in fact variables where your powers are multiples of 3. So if you had x cubed, or x to the 6th, or x to the 9th, etc., you have a power that's divisible by 3 and therefore is cube rootable. So these quantities are cubic. They're perfect cubes. Now what happens is you get these patterns then with cubes. So the difference of cubes is going to be designated by a cubed minus b cubed. So for instance, I could have something like x cubed minus 8. And this would be the difference of cubes, much like x squared minus 4 was the difference of squares. It's another factoring pattern. Now here's the deal. There is a way to factor these, so watch carefully. What the first thing has got to contain is the cubic roots. If you have cubes, they are the cube of something. So the cube root of x cubed would be x. Okay, oops, darn it. Stop. All right, let's start that back up. I apologize. I want to show you the pattern first. So the cube root of a cubed is a. Whoops. Cube root of a cubed is a. The cube root of negative b cubed is negative b. Now essentially what you're doing, guys, you've got variables with power 3. And when you do the cubic roots, those factors are each power 1, which leaves you with what I call square leftovers. And you can't, my pen doesn't write very well. So what you have to do to get the other part of this of this product is this. Square the a and square the negative b. Now negative b squared, negative b times negative b is not negative b squared, it's positive b squared. And then to get the middle term here, what you have to do is multiply these together, but change the sign. So in fact, if you multiply these together, you'd have negative AB, but if you change the sign, it's positive AB. And now you have exactly what you have to do to factor a difference of cube problem. All right, so we're going to take that on this particular problem. Okay, cubic roots. So the cubic root of x cubed, I hope you say that's x. The cubic root of negative 8 is negative 2. Use these guys to get this over here. Start squaring. So x squared is x squared. Negative 2 squared is positive 4. Now, that's fine and gets you the head and the tail. Again, to get the middle, you've got to multiply these together and just change the sign. So that would be negative to be positive 2x. And you just factored the difference of cubes.